I really hate this book or whatever online resource. When they run like the formulas, I don't really have trouble understanding it, but when they like write words, I'm like, I don't know what you're talking about. I don't understand everything. So I kind of sometimes skip down to where they just explain it in terms of the equations and stuff.
Yeah, yeah. That's how it
I
was
don't
for
know if
my
I'm
that's how it was for my calculus book.
yeah.
So,
Like, just stop talking. Just show me the numbers.
yep.
All right. So there was one part on part 2 where we were supposed to compare what the means are that you got.
Yeah. So
What was your mean?
I was going to do that right now.
Oh, okay.
Yeah, but then I thought so it's just like randomly select 5 and I'm like
Yeah. I
oh,
just went to the random.org or whatever. I didn't sit there and cut out the 30 squares.
oh yeah, I won't do that.
And they ask some really vague questions. Make a mark on where the mean is, and does that seem unusual to you?
Make a mark on the where the mean is. That
Yeah.
was one of the
So when you find out what your mean is for
oh
the 5
oh
salary,
yeah.
then we're supposed to make a mark on the graph on the next page. And then it says, does your sample mean appear to be unusual? I don't know. It's close to the regular mean. I mean, I don't know.
Yeah. So what did you get for your mean?
So my mean was 44,540.
So mine was 46,240.
240. So then if you marked it on the,
I'll be just
you're really close.
yeah. And I thought it was I don't know. I'm not much of the person that likes to randomly select only 5 out of 30. So
Yeah, I know.
it's like I know it's not gonna be right.
I know. Well, yours came really close though to the mean. But
Yeah.
then I mean, but mine was 44.5, which, was not too far off of the mean, but
Yeah, it's starting to get a little lower, yeah.
it doesn't appear to be unusual in the fact that you're not going to get exactly the mean if you randomly select ones. But anyway, I don't know. Explain why you think it is or is not unusual.
Um I chose 5 out of 30.
Yeah,
That's why it was
yeah,
unusual.
right, exactly. All right, I see that Dylan has tried to join. Are you there, Dylan? Your microphone's muted. I don't see your face, but your icon came up. We're just going to keep talking unless you join us. Did you have any questions on any of this? Oh, there's a face or an ear.
No questions.
No questions?
No.
It's nice to see you, Dylan. Is it Dylan or Bruce?
Dylan.
Okay.
The account is in my father's name, so that's why it pops up.
Okay. Nice to finally meet you.
Thank you.
All right. we're already recording. We went over. Did you do the part where you selected 5 of the salaries?
Yes.
And what was the mean of your sample?
Let's see, where is it? Let's see. Didn't exactly write it down.
Oh, it's okay.
Both.
That's okay. It wasn't. I'm sure it was around there. As long as we understand how we got all that,
Okay.
I'm good with that. All right. And then I guess the other biggest one is the difference between the central limit theorem and the law of large numbers. Do you guys understand the difference between the two?
Kind of.
It's so much of like blah 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 to me.
Yeah.
I understand the difference, but I don't know why there needs to be a difference. Like I don't understand anyway. So with the central, as far as I understand it, with the central limit theorem, the large sample size makes it so that the sample mean is approximately normal, approximately. Whereas the law of large numbers states that your sample with a large group, your sample mean will be close to the population mean, and the standard deviation will get smaller.
Hmm.
Do you get it?
Yeah, I don't know. To me, it's like all those, like how math has all those like theorems and stuff, but
I hate that word theorem because I did so poorly in geometry and I hated it.
oh, just like if you ever take calculus, there's a lot more theorems.
Yeah, I don't ever plan to take calculus. Ever.
Okay.
I don't need it, so I won't take it. All right, well, I guess we'll just go right ahead into the quiz. So when we've gone over our notes and made sure we didn't have any questions, Dylan, we usually just go in and do the quiz. So if you can pull it up in another window, then we get it all done together.
Okay.
I like how the lessons have been like fairly easy. The first part of the weekend, and the second part is just
A little harder.
Gets harder, yeah.
Well, it's almost like the first lesson of the week is more like definitions and stuff, and then the second part of the week is more actually doing the math.
Yeah.
And I kind of like that one better because it's just the numbers part. I don't like all the words. All right. So has everybody got their quiz pulled up?
Yep. And I got the applet pulled up as well, just in case.
That's a good idea. I'm going to do that also. Okay. So question number 3. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? Wouldn't it still be right skewed?
I would assume so, but I also feel like it's a trick question.
I know.
But it might just be my trust issue, so.
Well, okay, so because when you have 5, that's not a sufficiently large number to make it approximately normal. to me.
Yeah, because I looked at the next question and it's just n equals 100, and that's the only thing that changed. So I
Yeah.
feel like it might be normal for the 5.
Yeah. It might be normal for the 5.
Well, I don't know. I just think it might be normal because the 5 is so much smaller than the 100. So the
Yeah.
100 would be right skewed.
No,
Because,
because with the larger numbers, you get closer to a normal
oh, right. The
distribution.
larger numbers become more normal.
Yeah. The smaller numbers, it's not going to be as normal.
Okay, yeah.
That's how I understand.
That's that one theorem, isn't it?
Yes.
Yeah.
As with the CLT, I'm just going to say that. With the CLT, it states that if the population is normally distributed, then you'll have a more normal distributed whatever sample distribution. But if you have a not normal distribution of the parent population, you have to have like a larger number for it to approximate normal. That's how I understand it.
Yeah.
So I would say with 5, we're going to still be skewed right.
But then for the 100, it's the normal.
Yeah, yes. So then I would say that if you had 100, it's going to move more towards the normal. That's just my understanding.
Yeah.
We'll see it. All right. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the population is normally distributed? This one I would say would be normal.
Yeah.
You're quiet, Dylan. Do you have any insight for us?
I believe in the textbook it said anything that was under 30 wasn't going to be a large distribution.
Right. That's what I remember as well. All right. You want to take question number 6, Dylan?
Yes, it says that when you take a sample size of n equals 100, was the shape of the distribution histogram when the parent population is normally distributed? Since it's over 30, I'd say it would be normally distributed still.
Yep. I agree. All right, Alex, you're up.
When would the distribution of means be normally distributed? Choose all correct responses. So data are drawn from population that is normally distributed, and the sample size is small. Second one's the same except with a large sample size. Data are drawn from a population that is right skewed, and the sample size is small. Data are drawn from a population that is right skewed, and the sample size is large. So for me, it sounds like only the third one is incorrect.
That's what I got. All right. And number 7, which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. Yes. No, wait. If the sample size is large, the sample mean will be close to the population mean. No, that's the large numbers.
I think it's the last one.
If the sample size is large, the shape of the distribution of sample means will be approximately normal. Yes. I think it's the last one as well.
Because that's literally what the answer key said. So.
Yep. I agree. All right. We will submit and see. Oh, wait. Oh, we have more.
Oh, this 9 through 12 still.
I didn't move it down. Okay. So, all right, Dylan, you're up.
Okay. Let x be a random variable with population means equals 10 and population standard deviation equals 6. Suppose a sample size n equals 36 is drawn from this population. was the mean of the distribution of sample means?
So as far as I know, it's
10.
the same as the population mean.
Yeah, so it should be 10.
Yeah.
Well, yeah, it should be at least.
And then next question is wondered, what is the standard deviation of the distribution of sample means? So this is the one that we take the regular standard deviation, which is 6, and we divide it by the square root of 36. So it would be
So 1.
6 divided by 6 is 1. All right, Alex, you're up.
Regardless of the distribution of the population, if the sample size is large and greater than 30, what would be the shape distribution of the sample mean? That would be more normal, right?
Yeah. They said the book said for our purposes that anything over 30 is a large enough population or sample to make it normal.
Yeah. And for the last question, I put the CLT.
What term would justify your response to the last question? Yeah. See, that's where that one's close. But it does talk more about the law of large numbers is more towards the population mean, whereas the central limit theorem deals more with the distribution.
Yeah. Yeah, because I'm just looking over the what I had down, and I just had that, but law of large numbers that the standard deviation gets smaller. So
Right. That's what I'm saying. The
yeah,
law of large numbers deals mostly with the mean and the standard deviation, whereas the central limit
yeah.
deals more with the distribution.
So I'm going to go ahead and submit it now. And we got 100.
Yay! That's always a good thing.
Yep.
Yep.
The ones I always hate are like how question 7 was though. Like choose all correct responses.
Yes, those ones are hard. All right, we got it. And then, so we're set up for Thursday, same time. Does that work for you, Dylan?
Yes.
Okay.
I might be tired.
Are you going to be up all night?
No, I'm leaving for Hawaii on Wednesday.
Oh, so Thursday was the one that you were having trouble with.
So Thursday, Tuesday, and then next Thursday, I'm definitely not gonna be able to make it.
Okay. All right. I didn't look to see how much our class meetings are worth, how many points they're worth.
Well, I was just gonna watch it afterwards so I could
Oh.
get all the same answers as you guys.
Okay.
So I just won't get 2 points, I guess.
Is it 2 points that it's worth for going to the meeting?
I think so. And honestly, like
It is.
hurt it too much.
It's not going to. All right, I was worried about that because there's a week where I'm at girls' camp and I won't be able to meet because we have like row internet.
Girls' camp.
So much fun with the young women.
Yeah.
So, all right, so we're all set. So,
Yep.
Yeah, Thursday. I think it's just best to try and keep it where we can so that everybody can make it.
Yeah.
All right, we will see you then.
All right. Yep. See you guys around then.
All right, see ya.